Hai, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shazra'i bin Muhammad Azmi. Okay, my matrix number ID is MH20065. Okay, I am second year student from Mechanical Engineering in University Malaysia Pahang. For this subject is under by BMA 2312. That's it, Introduction of Automotive, conducted by Dr. Rizalman Mamat. Okay, today I will to present about the marine engine. So, let's go to the class. Don't skip the class. Hi class. Okay, for the firstly is what is marine engine? Marine engines on ships are responsible for propulsion of the vessel from one port to another, whether it's of a small ship plying in the coastal areas or of a massive one voyaging international waters. A marine engine of either 4-stroke or 2-stroke is fitted on board ship for the propulsion purpose. So next is marine propulsion. Marine propulsion is the mechanism or system used to generate thrust to move a ship or boat across water, while paddles and sails are still used on some smaller boats. Most modern ships are propelled by mechanism system consisting of an electric motor or engine turning a propeller, or less frequently in pump jets and impeller. Marine engineering is the discipline concerns with the engineering design process of marine propulsion system. Manpower in the form of paddles and sails were the first form of marine propulsion. Row galley, some equipped with sail, also play an important early role. The first advanced mechanical means of marine propulsion was the marine system engine, introduced in the early 19th century. During the 20th century, it was replaced by 2-stroke or 4-stroke diesel engines, outboard motor, and gas turbine engines on faster ships. Marine nuclear reactor, which appeared in the 1950s, produced steam to propel warship and icebreaker. Commercial application attempt late that decade failed to catch on. Electric motors using electric battery storage have been used for propulsion on submarines and electric boats, and have been proposed for energy efficient propulsion. Development in liquefied natural gas (LNG) fuel engines are gaining recognition for their low emission and cost advantage. Stirling engines, which are quieter, smoother running, propel a number of small submarines. In order to run as quietly as possible, its design is not used in civilian marine application due to lower totally efficient than internal combustion engine as power turbines. Okay class, let's focus to the next slide. Types of marine engines. There are several marine engine and propulsion systems out there, but the four main types are: firstly, diesel engines; second, steam engines; third, gas turbine; and lastly, the marine nuclear plants. Okay class, firstly is a diesel engines. Diesel engine, any internal combustion engine in which air is compressed to a sufficiently high temperature to ignite diesel fuel injected into the cylinder, where combustion and expansion actuate a piston. It converts the chemical energy stored in the fuel into mechanical energy, which can be used to power freight trucks, large tractors, locomotives, and marine vessels. A limited number of automobiles also are diesel powered, as are some electric power generator sets. Okay, next is a major type of diesel engines. They have two types of diesel engine. That's it, 3 basic size group and 2-stroke and 4-stroke engines. Okay, let me explain. The first one is a 3 basic size group. There are 3 basic size groups of diesel engines based on power: small, medium, and large. The small engines have power outputs value of less than 188 kilowatts or 252 horsepower. Okay, next, the second one, 2-stroke and 4-stroke engines. As noted earlier, diesel engines are designed to operate on either the 2 or 4-stroke cycle. In the typical 4-stroke cycle engine, the intake and exhaust valve and the fuel injection nozzle are located in the cylinder head. Steam engines. What is a steam engine? A steam engine is a machine that burns coal to release the heat energy. Its content so is an example of what we call a heat engine. It's a bit like a giant kettle sitting on top of a coal fire. The heat from the fire boils the water in the kettle and turn it into steam. But instead of blowing off uselessly into the air like the steam from a kettle, the steam is captured and used to power a machine. So, how a steam engine works? Crudely speaking, there are 4 different parts in a steam engine. The firstly is a fire where the coal burns. Second, a boiler full of water that the fire heats up to make steam. Third, a cylinder and piston, rather like a bicycle pump but much bigger. Steam from the boiler is piped into the cylinder, causing the piston to move first one way, then the other. This is an out movement, which is also known as reciprocating, is used to drive. And lastly is a machine attached to the piston. That could be anything from a water pump to a factory machine, or even a giant steam locomotive running up and down a railroad. That's very simple description. Of course, in reality, there are hundreds of, perhaps even thousands of parts in even the smaller locomotive. Okay, next is a gas turbine. Gas turbine engine, any internal combustion engine complying a gas as the working fluid used to burn a turbine. The term also is conventionally used to describe a complete internal combustion engine consisting of at least a compressor, a combustion chamber, and a turbine. How do gas turbine engine work? Okay, let me explain. As hot combustion gas expands through the turbine, it spins the rotating blades. The rotating blades perform a dual function. They drive the compressor to draw more pressurized air into the combustion section and they spin a generator to produce electricity. And lastly, what are the 4 types of gas turbine engine? There are 4 different types of turbine engines: turbojet, turboprop, turbofan, and turboshaft. Okay class, lastly is a marine nuclear plant. Nuclear marine propulsion is propulsion of a ship or submarine which heat provided by a nuclear reactor. The power plant heats water to produce steam for a turbine used to turn the ship's propeller through a gearbox or through an electric generator and motor. Nuclear propulsion is used specifically within naval warships such as nuclear submarines and supercarriers. A small number of experimental civil nuclear ships have been built. Okay, compared to oil or coal-fueled ship, nuclear propulsion offers the advantage of very long intervals of operation before refueling. All the fuel is contained within the nuclear reactor, so no cargo or supply space is taken up fuel, nor is space taken up by exhaust stacks or combustion air intakes. However, the low fuel cost is offset by high operation costs and investment in infrastructure, so nearly all nuclear power vessels are military.
The ship's marine engines are considered to be the biggest engines on Earth with massive power to propel a heavy loaded ship. There are different parts of the marine engine which helps the engine to rotate the crankshaft and propel the ship from one port to another. Each component plays an important role in powering and running a marine diesel engine. But the engine cannot run unless all components are in place and are in working condition. The main engine of a sea-going cargo ships are usually two-stroke internal combustion engines. The working of the two-stroke engine can be understood from this video. For a marine engineer or a professional working on ships, it is vital to know different engine parts and their function to operate and troubleshoot when needed. You must have seen the engine inside the machinery room of the ship, covered and assembled with different other auxiliaries. Let's take it out from its installation and only concentrate on the main engine to understand its different parts. But before proceeding further, please do subscribe to our channel and press the bell icon to get notified when we post a video. Looking at the exterior of the engine, it comprises of the following. Bed plate. Bed plate is the foundation block for two-stroke engine. It is built to withstand the constant force from the engine but is also flexible enough to handle constant fluctuations. A-frame. It is a fabricated steel structural element of a slow-speed two-stroke diesel engine. It stands on the bed plate above the main bearings. The A-frame carries the crosshead guides and support the engine entablature, also known as the cylinder block. Entablature. An entablature is a part of ship's main engine which houses the cylinder liner along with the scavenge air space and cooling water spaces. Turbocharger. Turbochargers are heat recovery equipment helping to enhance the efficiency of the engine by supplying fresh air. They are located near the cylinder block. Check this video to understand the turbocharger operation. Charge air cooler. Charge air cooler is a cooling arrangement for air supplied from the turbocharger before sending it to the combustion chamber. It is usually located below the turbocharger and adjacent to the scavenge space. Scavenge trunk. Scavenge trunk is a space where the cooled air from the charge air cooler is supplied for efficient combustion. Cylinder head. It acts as a lid of the combustion chamber and supports the exhaust valve and fuel injectors necessary for operation. Exhaust valve. The exhaust valve helps to draw out the exhaust gases post the combustion process. Know more about the functioning of marine engine exhaust valve in this video. Exhaust trunk. The exhaust drawn out of the exhaust valve is then transferred to the exhaust trunk, from where it strikes the turbine blades of the turbocharger for heat recovery. It is located in between the cylinder head and turbocharger unit. So these are the basic components which can be seen from outside of the engine. Now let's dive inside the engine to understand different rotating and moving parts that are involved in the propulsion process, that is, movement of the propeller. Liner. It provides a durable and heat-resistant combustion chamber, preventing combustion products from escaping into the engine itself. It is located at the top side of the entablature. Piston. Piston is used to convert the force of expanding gases into mechanical energy during the process of combustion. It moves inside the liner and is connected to the crosshead by piston rod. Piston rings. It seals the piston, therefore sealing the combustion chamber, preventing gases from leaking into the piston and surrounding areas. Piston rod. It carries the piston and connects it to the crosshead where the motion transfer takes place. Stuffing box. The crankcase is separated from the cylinder and scavenge space by a diaphragm plate on a two-stroke crosshead engine. The piston rod passes through a stuffing box which is bolted into this diaphragm plate. The stuffing box contains a series of scraper rings and sealing rings to seal and separate these two spaces. Crosshead. A reciprocating block which usually slides in guides and is the connecting point for piston rod and the connecting rod in a low-speed two-stroke diesel engine. Connecting rod. The connecting rod is fitted between the crosshead and the crankshaft. It transmits the firing force and together with the crankshaft convert the reciprocating motion to a rotary motion. Crankshaft. It is the main component behind transmitting power to the propeller shaft. The crankshafts on the large modern two-stroke marine diesel engine can weigh over 300 tons. They are too big to make as a single unit and so are constructed by joining together individual forgings. Camshaft. The camshaft carries the cams which operates the fuel pumps and exhaust valves. Because these operate once every cycle of the engine, the camshaft on a two-stroke engine rotates at the same speed as the crankshaft. Gear drive. Camshafts are driven either by gears or chains. In the case of gear drive, a train of gear wheel is fitted which transmits the drive from the crankshaft to the camshaft. If you found this video useful, please do like and share it, and don't forget to subscribe to our channel.
So class, do you understand what the video talking about? So, we continue the new subtopic, the benefits of marine diesel engine. There are 4 benefits of marine diesel engines. The first is a lower fuel cost. Second, less flammable. Third, energy efficiency. And lastly, longevity. So let me explain the 4 of benefit marine diesel engines. Lower fuel cost. While both marine gas oil (MGO) and marine diesel oil (MDO) constantly fluctuate in cost, on average, diesel costs less than gasoline. In an article published in boats.com, it was found that diesel averaged at $2.50 per gallon, and while marine gasoline averaged $2.97. While this may not seem like a significant difference for larger vessels that cruise frequently, diesel ends up being the more economical choice. So, saving money on fuel is one of the most thought benefits of marine diesel engines. So, the second of benefit of marine diesel engines is energy efficiency. In general, marine diesel engines have greater efficiency and economy than their gasoline-powered counterparts. In an article published by the Universal Technical Institute, they found that diesel engines are 20% more thermal efficient than gas engines on average. As a result, their fuel economy increased by 20%. Diesel fuel has more energy potential per gallon than gasoline, which means diesel-powered jets travel more with less fuel. So class, we move to the third point of benefit marine diesel engine. That's it, less flammable. Another advantage of diesel engines over petrol engines is safety. Diesel is much less flammable than gasoline. Only intense pressure and sustained flame can ignite diesel. Diesel fuel has a flash point between 52 and 96 Celsius, 126 and 205. In comparison, gasoline is a flammable liquid with a flash point of negative 14 Celsius. It gives enough vapor to create a burnable mixture in the air or the bottom of a boat. For lower flammability risk, a marine diesel engine is the safer option. The last point for the benefit of marine engine is longevity. Marine diesel engines are known for their longevity. Gasoline engines are made up of much more parts and therefore more likely to break down. The average marine gasoline engine runs for around 1,500 hours before requiring a major overhaul by marine rebuild specialists. In comparison, a well-maintained inboard diesel engine typically lasts around 5,000 to 8,000 hours without a major overhaul. If you want to own a larger yacht and expect to use it regularly, pick a long-lasting marine diesel engine. Okay class, for the new subtopic is how does marine engine work? Okay, marine engines on ship are responsible for propulsion of the vessel from one port to another. Whether it's of a small ship plying in the coastal areas or of a massive one voyaging international water, a marine engine of either 4-stroke or 2-stroke is fitted on board ship for the propulsion purpose. The marine engines are heat engines used for converting heat, which is generated by burning fuel, into useful work, developing thermal energy and transforming it into mechanical energy. The engines used on board ships are internal combustion engines, a type in which the combustion of fuel takes place inside the engine cylinder and the heat is generated post the combustion process. Okay class, and the last is where are marine engines made? These marine engines are built at the facilities of the manufacturer. For example, MAN Diesel has production facilities in Augsburg, Copenhagen, Friedrichshafen, Saint-Nazaire, Shanghai, and others. Similarly, Wärtsilä has facilities in Finland, Germany, China, and others. The ship's engine can also be made in repute shipyard if there is a contract between the two companies. And the last point is the engine is usually made in 3 different sections, and depending upon the size of the engine room and access for the installations, it can be fitted in the shipyard either in section or as an entire assembly. Okay class, the class will end here. That's all from me. Sorry if there is anything wrong or mistaken during my teaching. Hope you all can focus well on this video, and thanks to Dr. Rizalman Mamat. Without him, I will not be able to succeed this video. Thank you very much. Bye. Assalamualaikum.